Hello, everybody. I don't know what happened to the other recording that I had, but it got corrupted somehow, kind of like my ex-wife. Um, okay, and again, I know you've heard this, but excuse me, the final exam will be next Tuesday, the 13th, and you must have it finished by 12 o'clock noon. Now, I'll email it to you uh, probably Monday. Email me back your answers. I'll send you a an answer sheet if you want to use that. First thing we did was we talked about uh, solving quadratics. Now, the solutions to quadratics are called roots, zeros, or solutions. There's no telling what these people will ask you for, but they all mean the same thing. Roots, zeros, and solutions mean the answers. The first thing you do is you set the quadratic equal to 0. You factor the quadratic, set each factor equal to 0, and then solve it. So if we have this, a squared minus 9 equals 0, this is, hopefully you'll remember this, excuse me, this is called a conjugate because there's no linear term and it's the, excuse me, it's the difference of two perfect squares. So it'll factor into x plus 3, a plus 3, and a minus 3. And if you multiply those out, you would get back to a squared minus 9. Now you set each one of them equal to 0. A plus 3 equals 0 and a minus 3 equals 0. You solve the equations so you get a is equal to negative 3 and positive 3. And you plug them back in, you can, to make sure they work. At some point, you're going to get someone that will ask you, um, will require you to plug these back in because you're going to get one answer or both of them that do not work. When I say do not work, if you put 3 squared minus 9 is 9 minus 9 equals 0. So it works. It's exactly the same. But at some point, you're going to get some that do not work or that do not answer the question properly. So now if we have this, if we have y squared equals y plus 20, remember the first thing you do is you set it equal to 0. I'm going to go kind of fast here. And of course you can stop and start, you know better than I do. Okay, we want to set this equal to 0, so we're going to subtract y and subtract 20 from each side. So then we get minus y minus 20. So now we get y squared minus y minus 20. Now we want the factors of 20 that add up to, excuse me, negative 1. Remember, this is 1. So it's 4 times negative 5. 4 times negative 5 is, that should be negative 20. Okay, so we have y plus 4 and y minus 5 equals 0. So you set each one of these equal to 0. So y plus 4 equals 0 and y minus 5 equals 0. Subtract 4, subtract 4. So y equals, this is 4. Y equals negative 4. And you add 5, y equals 5. Okay? Okay. Now, this is the review. For your final exam. Number 1. These should go right along with your final. Should be very similar, if not exact. So if you have this, if you have 3x plus 3 minus 7, open x plus 1. This looks real hard. Well, it's not. It's just long is all. 2x minus 3. First thing we do is we have order of operation. Do we have parentheses? Yes, but there's nothing to do in there. So we're going to multiply the negative 7 times everything inside here, and we get 3x plus 3 minus 7x minus 7 equals 2x minus 3. And we multiply the negative 7 times everything in here, and we get this. Now we combine like terms. 3x, negative 7x, 3, negative 7, and we get, let's see, negative, was it negative 4? Negative 4x minus 4, okay, negative 7 plus 3 equals 2x plus 3. Now the best way of doing this is add 4x to each side. That way you get rid of these godless negative numbers. And we get negative 4 equals 6x plus 3. Now we subtract 3 from each side, and we get negative 7 equals 6x. I'm doing something wrong here. What a bonehead. Minus 3, minus 3, minus 7. What did I do wrong here? Bonehead, 2x. This is supposed to be minus 3. I'm sorry. So we're going to add 3 to each side, and we get negative 1. I'm sorry. Divide by 6, and then x equals negative 1/6. Okay, I'm sorry. Fouled that up, of course. Okay, number 2. Okay. We have 3x minus 7 over 4 plus x over 28 equals x over 7 minus 2. Okay, I'm going to get this over here. We're going to subtract x over 7 from each side, and we get this. 3x minus 7 over 4 plus x over 28 minus x over 7 equals negative 2. Okay, now we have to have excuse me, to be able to add these, we have to have a common denominator, and it's going to be 28. So we're going to multiply this side by, what do we have to do to 4? What do we have to multiply 4 by to get it to 28? 7. We're going to multiply by 7 over 7. Now 7 over 7 is 1. So we're not going to change the value of this any. We're just going to change the look of it. And that will give us 21x minus 49. I would multiply 7 times everything over here over 28 plus x over 28. That one's already has 28 as its denominator. Minus x over 7. Now what do we have to multiply 7 by to get it to 28? Is it 4? 4 over 4. And again, 4 over 4 is 1 equals negative 2. Okay, so now we combine like terms. What we can do is, I'm going to move this up here. I'm going to put this all in the numerator here. 21x minus 49 plus x, okay, plus this one, minus, this is 4x over 28 minus 4x, right? All that over 28. Since we're adding and subtracting and they all have the same denominator, we can do that. Now we combine like terms. 21x plus x minus 4x. And don't forget the minus 49. So we get 20 minus 4, 16x, 21. Wait a minute. I've dropped a sign here somewhere. What have I done? Oh, this is minus. Oh boy, see what happens when I get in a hurry. Okay, so we have 21x minus 1x is 22. And 22 minus 4 is come on, stupid thing. Come on. 21, 20. Okay. Oh, this was right. Bonehead. So that is 22 minus 4 is 18. I'm sorry, it was this. Okay. Plus 4x. And don't forget the 40 minus 49 over 28. Equals negative 2. Now one of the things the fraction bar does is it puts everything, this is one term up here. So how do we get rid of the 28? This is all this misery here divided by 28. So how do we undo undo division, multiplication times 28 times 28. Excuse me. So we get 18x. Okay, this is gone. Minus 49 equals negative, what is that, 56? I think so. And we add 49 to each side. And we get 18x equals negative 7. So we divide everything by 18. And we get x equals negative 7 over 18. Okay? Okay. What fun is that? You'd love to get your hands around the throat of the person that makes this up. Okay, number 3. Number 3 is godless decimals. 0.40x minus 0.20 times 50 plus x equals 0.04 times 50. Now this is where your handy dandy calculator is going to come in handy. The first thing we'll do is we're going to multiply negative 0.2 times everything in here. So we get 0.40. Actually, you could just put 0.4. Means the same thing. Excuse me. Negative 20 times 50, I think, is negative 10, but my brain's gone numb. Negative 0.2 times. Oh, what a smart boy Johnny is. Minus 10 minus, remember this is negative 0.2 times that negative 0.20x equals, and 0.04 times 50 I think is 2. But let's make sure. 0.04 times 50. Be sure and look up here and make sure you entered it right. Yeah, 2. Okay, combine like terms. 40x minus 0.40x minus is 0.2. Is that right? Or 20x minus 10 equals 2. And we add 10 to each side. Very simple algebra here. Point x equals 12. And we divide by 0.20, and then x will equal 60, I think. 12 divided by 0.2, I think is 60. Number 4. Okay, they want this in interval notation. If we have this 20x plus 45, this is actually a real simple algebra problem. It just has these inequality signs. 5 open 3x plus 18, 3x plus 18. Now remember, when we solve these, excuse me, we solve these just like equations with one exception. If you multiply or divide by a negative number, the signs flip. We're talking about this sign right here. Okay, so we have 20x plus 45 is greater than, now we distribute the 5 over everything in here, 15x plus 90, I think. Okay, subtract 15x from each side. Now let's go ahead and subtract the 45 now also. So now we have 5x, that's gone, is greater than, was it 45? That's gone. 45. Divide by 5, then x is greater than 9. That's not the answer. They wanted an interval notation. Now remember, interval notation, if it's less than or greater than, we use parentheses. If it's less than or equal to, greater than or equal to, we use brackets. This is where you get yourself a cough drop because you've been drinking too much Diet Coke. Okay. It's going to look kind of like this. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, this is greater than. The numbers get bigger this way. And this side is less than. Now, 9 is right here. Now, x is greater than, more than. So we use a parenthesis. And it goes forever. Now, this is where you have to really pay attention. When I was doing this, I made a mistake. It's what's on the low side, what's the least this number can be? 9. What's on the high side? Positive infinity. Now, it does not include, remember the interval notation just mimics this. That's here and here. This is the answer. One of the answers is going to be this. And that's where I made a mistake because I didn't pay attention. That's wrong. This is correct because it does not include 9. Now, number 5. If you have negative 13 less than or equal to negative 2x, Now we're going to have to divide by a negative number, so all of our signs are going to flip. Minus 3 less than or equal to negative 11. Now you do this just like a regular equation, except you've got 3 sides to this thing. So whatever you do to one side, you have to do all of them. So first of all, we're going to add 3 to all the sides. And this is going to give us negative 10 less than or equal to negative 2x less than or equal to, that's gone. What is that, negative 8? Something like that. Okay, now we're going to divide everything by negative 2. And this is where you go equally. All the signs are going to flip. Negative 10 divided by negative 2 is a positive 5. Now, it becomes greater than or equal to x. Again, greater than or equal to 4. So what's this going to look like on the number line? 1, 2, 3, 4. Okay. Now, if you look at this, x is now less than or equal to 5. Here's 5, so less than or equal to is going to be like that. And here, x is greater than or equal to 4. All these numbers in here. So our answer here is 4, 5. If they ask you for, I think they just wanted this. But the 4 is going to be at the beginning. So 4 is less than or equal to x, which is less than or equal to 5. A lowest number like that. Okay. What was that? Number 5. Number 6. Okay. Now this one I'm going to give you the answer to. I don't know why, but they love this problem. It's on just about every math test you'll take. Okay, they want you to solve this for x. Okay, just imagine there's a number here and here. What would you get rid of first? You'd subtract the b from each side. So you have y minus b equals mx. Now this is m times x. How do you undo that? You divide by m. So here our solution is x will be equal to y minus b divided by m. Number 7. You have a rectangle. The length is 6 more than twice the width. The perimeter is 156. Okay? So let's draw a nice pretty picture. Now what do we know about rectangles? Opposite sides are equal and parallel. This equals this and this equals this. This is the width and this is the length. The length is, now look, just take these real slow and do it one at a time. The length is 6 more than. How do you write 6 more than? Plus 6. Twice the width, what does that mean? 2 times the W. Twice the width 6 more than. So what is this? The width is just W. Now remember, opposite sides are equal. So if this one's W, this one's W. And this one is 2W plus 6. Now you can do this several different ways. You can do it 2W plus 2 times 2W plus 6. Or you can just write them 2W plus 6, 2W plus 6, plus W plus W. And all this adds up to 156. Two W and 2W is 4W, 5W is 6W. 6W plus 12 equals 156. Very 6, bonehead. Okay, now we have real simple algebra. Subtract 12 from each side. And we get 6W is 144. Is that right? I think so. Now divide by 6. W is 24. Now, is this our answer? No. They want to know what the length of each side is. So we know the width is 24. And the length is 2 times 24 plus 6. That's 48 and 6 is 54. So our length is 54. Okay? Okay. Number 8. I didn't have enough time to go over this one, I'm sorry. But the answer here, A-N-S-W-E-R, is C, the letter C. Okay. I'll do better next time. No, probably won't. They're probably going to fire me first anyway. Okay, number 9. Write in standard form. Now, standard form is AX plus BY equals C. Okay, this is standard form. Now, A must be a positive whole number. Okay, this number has to be positive and a whole number. Now, if you're given, okay, through the points, THROUGHOINTS. Through the points, 4 comma negative 6 and 0 comma 7. Remember, excuse me. Remember, these things are always written in the form XY. Now, this is the first coordinate, so we're going to call it X1 and Y1. This is the second one, so we'll call it X2, Y2. But it doesn't make any difference. This can be X2 and Y2, and this one can be X1 and Y1. Now, what's the one thing that we can calculate from slope? From 2 points is slope. Remember, we call slope M for some reason. And that is Y2 minus Y1 over X2 minus X1. So our Y2 is 7 minus a minus 6 divided by X2 is 0 minus 4. Remember, minus also means the opposite of. So this is actually 7 plus 6 over negative 4, which is 13 over negative 4. Now that's our slope. Right. So now what do we have? We have 2 points and the slope. So what formula we're going to use? Oddly enough, point slope. Yeah, point slope. Y minus y1 equals m open x minus x1. And remember, this x and this y stay x and y. Now, we take one of the points. Either one, doesn't make any difference. Let's take this one because the numbers are easier. So we have y minus 7, right, equals m, or m is negative 13 over 4. And x1 is 0. So we have y minus 7 equals negative 13 over 4x. Okay, we're going to multiply this times everything inside here. And then that times 0, of course, is just going to be 0. So now we add 7 to each side. And we get y equals negative 13 over 4x plus 7. Okay, now remember, standard form is this. We want to solve this equation for the constant. In other words, we want the constant over here by itself. So we're going to add 13 over 4x. This is 3. Okay. So what do we get? We get negative 13 over 4x plus y equals 7. That's gone over there. Now, this number needs to be positive, and it needs to be a whole number. Hang on just a second. Do that. Okay, now how are we going to make this into a whole number? We're going to multiply everything by 4, this number here. Actually, what we need to do is multiply by negative 4, so this will be positive. Okay, that cancels out. It makes that a positive 13x minus 4y equals negative 28. Oh, bonehead. That was positive. I'm sorry. I'm sorry. Here we added 13 over 4x to each side. But the procedure's still the same. Good Lord, look at that problem. Whew, that's a good one, huh? Mm-hmm. Right in slope-intercept form. We have our slope is negative 3 through THROUGH negative 7, negative 7. So what do we have here? We have the slope and we have a point. So what formula we're going to use? Oddly enough, point slope. Y minus y1 equals m open Well, I wish I had $1 for every time I've written that formula. That one on slope. Now we just plug in the numbers we know and solve the equation for y. So we have y minus, remember this is x, this is y, minus 7 equals m is -3, open, x minus a -7, closed and closed. Okay, so we have y plus 7, minus a minus is a plus, equals -3x. Now this is going to be a positive 7. This is positive 7, minus 21. Is that right? I think so. Now we subtract 7 from each side because we want y over here by itself. Y equals -3x minus 28. Oh, this was number 10. Number 11. Write the equation, or ITE, with an undefined slope through -3/4 and 7. Okay, remember an undefined slope is up and down, straight up and down. So I have to draw pictures, I'm sorry. -3/4 is about right there. An undefined slope will be like this. Right? So the way you can look at this is no matter what y is, if y is 0, x is -3/4. If y is 10, then x is negative. It's always -3/4. So how can we write this? X equals -3/4. Okay. Now number 12, if we have y minus 2 equals 0, is this in slope-intercept form? No. Because remember, we want y here by itself. So we add 2 to each side. So y equals 2. Is this in slope-intercept form? Yes. This actually means y equals 0x plus 2. Our slope here is 0. And what's the slope of 0 look like? Horizontal line. So what will this look like? Y is 2. So it's going to look, pretend that's a straight line. So it's going to look like that. And this is what your problem looks like. Looks like that. Okay, and here's the answer. Y is 2. And if you have a graphing calculator, you can put in there, go to y equals, and put in 2, and it'll show you what the answer is. Okay, graph by using the intercepts of -6x. Sorry. -6x minus 18y equals 18. Okay, to find the x-intercept, you set y equal to 0. In other words, what you're going to do is just eliminate that. And you get negative 6x equals 18. Okay, so we divide by negative 6, and x is negative, what is it, 3? Come on, stupid think. I think that's right. Now to find the y-intercept, do the exact opposite. You set x equal to 0, and that just eliminates that term. And you get negative 18, y equals 18. Divide by negative 18, y equals negative 1. Okay, so here's y. Negative 1 is about right here. And x is negative 3. That's about right there. So our will look like that. And again, you're going to get this. The x-intercept is negative 3. The y-intercept is negative 1. And there you have it. Okay. Number 14. Okay, graph y equals 4 over 5x plus 5. Okay. Now remember, we can also define slope as rise over run. In other words, how much does it go up or down versus how much does it go side to side? Now, we can start at one point. One point we know that it crosses the y-axis at 5. 1, 2, 3, 4, 5, right? And the slope is 4 over 5. So it's going to rise 4, 1, 2, 3, 4, and run 5, 1, 2, 3, 4, 5. Okay? Number 15 says this. All positive exponents. E-X-P-O-E-N-T-S. Okay, so if we have xy to the 6th, xy to the 6th over x to the 4th y, all raised to the negative 2 power. Now remember, when you have powers raised to powers, you multiply. Now this x is actually 1, we just don't write it. Same with the y. So what does this equal? If I were you, I'd draw the fraction bar. Now take them one at a time. X to the 1 times negative 2 is x to the negative 2. Y to the negative 12. Remember, you take the exponents and you multiply them when you have an exponent raised to an exponent. And you have x to the negative 8, y to the negative 2. Okay? Now to make the exponents positive, if they're negative, move them. If they're in the numerator, in the top, move them to the bottom. Draw the fraction bar, take them one at a time. is going to be x squared. Okay, when you move them, they become positive. Y squared up to the 12th power, x to the negative 8, x to the 8th, and y squared. Now here we have like terms. Now when we're dividing, we subtract the exponents. This is going to be x to the 6th over, there's more y's in the denominator in the bottom than in the top, so it's going to be y to the 10th. $16 x squared over 6, this one's to the 4th power, 6x all cubed. Okay, so this one is x to the 8th. And remember that the 6 has an exponent too, it's 1. And we're going to cube everything in here. So it's going to be 6 cubed x cubed. Okay, now we have x's. So this is going to be x to the 5th, remember, because we subtract the exponents. And 3 cubed, I think, is 216, I think. Okay, okay. I'll see you Thursday. Bye-bye. Bye, Bonds.